we've completed exercise 3, which is really the crucial group of problems. So make sure you're really comfortable with exercise 3 problems, or you practice that type a lot. There are several from the textbook. Also, there's an extra homework assignment on finding formulas for inverse functions. We're now going to move on to something called restricting the domain, which is tricky and hard and a little bit subtle. And so if it's just driving you crazy, I wouldn't worry about it too much, but if you want to get everything down just right, you do have to try to follow this discussion. So here we go. If a function is not one-to-one, it may be possible to restrict the domain of the function in order to create a technically new function that is one-to-one, and the new function with restricted domain will have an inverse. So here's an example. The function f of x equals x squared that we know so well, with domain minus infinity to infinity, all real numbers, does not have an inverse. However, we can restrict the domain of f to obtain a one-to-one function that does have an inverse. So we can define, technically it's a new function based on f of x equals x squared. And what we're going to do is we're going to say it has domain 0 to infinity. So we're going to take that f of x equals x squared parabola that we're so familiar with, and we're only going to take the right half. We're going to take the right half. That's what it means when we say we're restricting the domain from 0 to infinity. That's 0 to infinity of x values. So we're saying I just want half a parabola, half a quadratic here. And this function does have an inverse, and its inverse is this square root of x function. In fact, that square root of x should look like it's related to half a parabola, and there is a connection between each of these two halves. Now, I want to go through this with an actual exercise. So we're going to leave example 6 behind and go on to exercise 4. We're going to work with a slightly different function, f of x equals x plus 5 squared. And again, this is not a one-to-one function, so we're going to restrict the domain to obtain a one-to-one function, and then we're going to find an expression for the inverse, and then we're also going to decide what the domain and range of the inverse are. So, okay, this is a little bit involved. I think this is a little bit tricky. So first of all, what's the graph of this function look like? At this point, you guys shouldn't have much trouble visualizing that. I'm actually not using a sheet of graph paper here, am I? Because I know this is just the graph of x squared transformed, shifted 5 units horizontally to the left, right? So that turnaround point is going to be at -5. And that parabola is going to kind of be in a position like so. Here's the x-axis, the y-axis. So here's the graph of x plus 5 squared. Now, this is not a one-to-one function. Not one-to-one. So we can't find an inverse. But what we're going to do is restrict the domain. Now, not like we did in the example we just talked about, because that was a slightly different function. What we want to do is something similar here, but we want to get half a parabola, right? Half the parabola if we can, to obtain a one-to-one function. So I'd like to be able to just take maybe this portion from -5 on and on to the right. That means we're going to take a domain from -5 on and on to the right. So I'm going to say restrict the domain to square bracket -5 infinity, and then our graph is going to look like this, right? Here's -5. We're going to have that point at -5, 0, and we're going to have just this branch going up like so. Eventually it crosses the y-axis. So we have half of a parabola And this is 1-to-1. So there is an inverse. Okay. Now, find the inverse of this function with restricted domain. Okay. Now, the formula is the same. That hasn't changed. But I'll say with domain restricted to -5 to infinity. So that means just half the parabola. The steps are the same, where we replace f of x with y. And we got to solve for x. So I'm following my yellow card steps. But now, see, to solve for x here, I got to take square roots. So far, we've looked at some examples with cube roots where you only get one cube root. But with square root, you get 2. Yeah, got to write plus or minus the square root of y equals x plus 5. Okay, so I've taken square roots, but I have to consider both at first, at least. And I guess way back somewhere in this course we talked about the problems. If you get the plus or minus, you might not have a function, right? And so now here we actually can make a choice as to plus or minus signs. So here's what's going on. Because the domain is restricted to this interval, x is greater than or equal to -5. So that means x plus 5 is greater than or equal to -5 plus 5. X plus 5 is greater than or equal to 0. So x plus 5 is positive here. Positive here. And so that means we know with this restricted domain, we want the positive square root of y. Okay. And that's because the domain is restricted. Because of domain restriction. I know that's a real subtle argument. And now, subtract 5 from both sides. I got x solved for. I'm going to do my switch. So I have square root of x minus 5 equals y. And I'm running out of room. I'm going to also switch to another sheet of paper in a moment. Let me rewrite this as y equals the square root of x minus 5. I just want to write y in front, so no manipulation there. I'm just rewriting the equation. And then f inverse of x is the square root of x minus 5. Okay, so we found our expression for the inverse function. Let's see, we restricted the domain. We did that. We found an expression for the inverse function, and now they want us to describe the domain in range of that inverse function. So I'm going to go to another sheet of paper. So where are we at now? We started with this. With domain restricted from -5 to infinity, right? Oops, sorry. So that's the function we started out with. We got f inverse. Now which I'm copying from my other sheet, is square root of x minus 5. Only the x is in the square root sign. And there's no restriction here. Now I also want to bring this graph back of the restricted function. So it was half a parabola with its turnaround point at -5, went kind of off like that, right? That was our original function. To describe the domain and range of the inverse, I want to draw this graph. Now we already know what the square root of x graph looks like. That's in our toolkit. That's not what we want here. We want square root of x minus 5, right? So let's leave that off to the side. This function's graph is going to be the square root graph shifted down 5 units. It's actually going to start at -5 on the y-axis, and then it's going to kind of rise up like so. And so this is a graph of f restricted. This is a graph of the f inverse that we got. Okay. And now the domain or range of f inverse. Domain of f inverse is, well, now that's x coordinates used. So it's got nothing to do with -5. I mean, we need this point, but the domain starts at 0 to the right. So for the inverse, the domain is 0 to infinity. And we could have figured that out from the square root expression, by the way, because just x is all by itself inside the square root. But I wanted the graph because it's easier to see the range. The range of f inverse, now that's the interval of y values used, that starts at -5 and extends to infinity. So there's the domain or range of f inverse. I wanted the graph to be able to, because I think they ask us for the domain or range of the inverse function. Now, just as a matter of reference here, we already knew the domain of f was restricted to this interval -5 to infinity. Notice how that restricted domain of f becomes the range of the inverse. That's exactly what happens with an inverse function. And the range of f we can also see from its graph. Now that's y values used by points on this graph, right? So the range of this, even the restricted function, is y values from 0 to infinity. And just notice the range of f, the restricted f, becomes the domain of the inverse. See how the domain and range trade places there? That's kind of interesting. Okay, enough of that. We went on long enough with that one.